We now turn to the next hypothesis testing problem. We have a physical fitness program on 100 subjects. For 80 of the subjects, after doing exercise, the pulse rate goes down. For 17 of the subjects, the pulse rate went up. And for 3, the pulse rate stayed the same. Determine if the pulse rate has gone down at the 1% level of significance. Okay, so for this problem, we define pi to be equal to the probability that for somebody that the pulse rate goes down. The null hypothesis will be that simply that pi is equal to 1/2. One of the rates has to be different than the other. If there's a difference, then there's a 50% chance that the first one was higher and a 50% chance that the second one was higher. So the null hypothesis will say, well, it's just simply dumb luck then that the pulse rates went down for these folks, but the pi is really equal to 1/2. Half of them should go up, half of them should go down, just by, because of the ineffectiveness of the exercise program. The alternative hypothesis is more optimistic and says, no, pi is greater than 1/2, because we think that this exercise program was good, and that because of doing this, the people's hearts are stronger, and so the pulse rate should go down as a result of the experiment. Now, in this particular study, there's actually 97 subjects. 97 because for 3 of these people, the pulse rates were the same. So we have that n is equal to 97. The test statistic in this case is 80. And we have our level of significance is given in the problem to be 1%. So the p-value is going to be the probability of seeing a test statistic this extreme or more extreme. I would have expected half of 97, which would be 48.5 successes. I really got 80 successes. So we compute the probability that a binomial random variable would be greater than or equal to 80, which is equivalent to saying that the binomial random variable is less than or equal to 79. That I compute with either Excel or else a calculator. Binom dist 79, 97, 1/2 true. And so I compute this using Excel or else a graphing calculator. So a third possibility, which is not required, but it is certainly a possibility, would be using the bell curve to approximate this probability. And I get a very small number, 3.039 times 10 to the minus 11th. That number is significantly smaller than 1%. And so let me type down here the conclusion that we reject the null hypothesis. It appears that the exercise program did decrease the at-rest pulse rate. Okay, so this is an example of hypothesis testing using the binomial distribution.